Hello, welcome back. We've got a couple of problems to solve today, starting with single number 136. Given a non-empty array of integers, every element appears twice except for one. Find that one. Find that single one. You must implement a solution with linear runtime. Every element appears for one except one. Okay. Think about XOR. Yeah, I was thinking about XOR. So I know exclusive OR XOR. So well, let's start with OR. Right? 0, 1, 0, 1, 1, 1. Zero. This is OR table. We know it's one. In our case, if either one is true, then the result is true. In the case of exclusive OR, well, it's just opposite of this OR. So okay, right, just okay. This is true, this is false, this is false. So 2 and 2, because they are same values, it should give us binary level. Okay. Int result. But I've forgotten the exact working of the XOR. But let's say I know it works at binary level. So what's 2 in binary? 1 1 1 0 0 0 0 1 1 0 1 0 and 1 0. Now 0 0 is, well, we have seen false, true, true, and false. Okay, so 0 0 is false, and yeah, it's false. 0, so it should return 0. Okay, if we XOR two numbers having, if both of them are same, then we'll get 0. You can just verify this. System.out.println return it's a up. So then it's pretty easy. For if we XOR anything by 0, then we get a 0, right? Let's see. If int num dot nums, for each number in nums, XOR with result and return the result. Okay. I think anything XOR with 0 should return that number. Yep. Let's just verify. I think it should return the number. 2 XOR 0. Okay. Next. Same tree, binary tree problem. Easy. Given the roots of two binary trees P and Q, write a function to check if they are same or not. Two binary trees are considered the same if they are structurally identical and nodes have same values. Okay. This one is false. The tree is not it's structurally not same. Okay. And here the nodes have different values. So depth first search. So what we can do is we run a depth first search. We'll start. We'll end up here, and we'll compare with this node, and then the moment we come across nodes that are not equal, we return a null. Okay. Makes sense. So we can say if P is null and Q is also null, then return true. If P is null or Q is null, then return false. And for checking the values, if P dot value is not equal to Q dot value, then we would like to return false. false. Okay, now the recursion step. Hmm. Return is same tree, left q dot comparing, let's okay, comparing first going to left side, and then you can just copy this. And right, p dot right, q dot right. Okay, it's same tree. Okay, we are verifying the root. You're checking. Okay, then we are finally verifying the values. Can I do something like oh god, my mouse I think is losing battery. Else return false. I don't know why I changed that, but let's see. Give me an edge case. Give me an edge case. No, works fine. Oops, yeah, you would have gotten edge case in this one. 1 to 3. 1 to 3. Expected true. Oh, 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 oh. Just want to take a look at Kotlin solution. Kotlin. Yep, when condition. When. I like Kotlin really much. I like Kotlin very much. Okay, next question. Roman to integer. Roman integers, Roman numerals are represented by 7 different symbols. IV, XL, CDM. Convert. Problem is simpler to solve by working the string from back to front using a map. Okay. So this one, this Roman number, if we start, we're starting. Okay, we're starting from the V. V means 5. Yes. CM. Well, this, okay. This whole thing means this is 4. So we can have a condition if this is if this Roman letter, it's if this Roman numeral is smaller than its next numeral, then we need to subtract, and the rest is very easy. Result 0, a map, hash map map of what, characters and integers. Map is new map, new hash map. Just say right and okay, and map dot put. Let's copy this, paste it everywhere. Okay, cool. Map is ready. Now we need to go through the input in reverse order. So I can say for I is equal to s dot length minus 1. I is when as long as I is greater than minus 1, I minus minus and character char current. Hang on. I should start from this one. Okay. Current is s dot char at I. If I is greater is smaller, 0 1 2 3 4 5 6 3 4 1 2 3 4 5 6 7. While I is smaller than string's length minus 1 and and current is map. Hang on. I need an integer. Int current int map dot get current int. If current integer is smaller than the next one, so map dot get s dot character at I plus 1, then we basically subtract from result. Yeah, we subtract result minus equal to current int, else we keep adding to the result. Current int. This should work. I'm very positive it will work. And it does. Okay, cool. Let's look at my previous solution. Last one was submitted on 23rd October, almost 2 months ago. Yeah, I did same thing last time. As for each, getting the value from map, value is last. Value is greater than. Okay, yeah, this approach is also good. If you don't want to iterate the array backwards. This is so good. Map.it. Last multiplied 2. That's interesting. Previous value. If this value interesting. Okay, time for a harder one. 1 to 7 word ladder. A transformation sequence from word begin word to word end word using a dictionary. Word list is a sequence of words. Every adjacent pair of words differ by one letter. Okay, we are given a word begin string and a end word string, and we are given this dictionary word list of words. Given two words begin and end and a dictionary, return the number of words. Return the number of words. We have to return the number, not the actual words. Okay, in the shortest transformation sequence from begin to end or 0 if no such sequence exists. So starting from hit till cog, we have to return a sequence. We have to return the number of words in this sequence, which is a begin word. It starts with begin word S1, S2 such that till Sk such that every adjacent pair of words differ by a single letter. For every S1. Okay, note that begin word does not need to be in the word list. The last, okay, so the begin word doesn't have to be in the list, but the end word has to be. So we start with hit word list. one shortest transformation sequence is hit, starting with hit hot, okay, dot hot dot dog 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 cog. There should be a change of only one letter in subsequent words. So here I changes to O, here H becomes D, here D becomes G, here D becomes C. Okay, so the idea is that, well, we start with some initial word, hit, let's say hit, and okay, we start with hit, we change one letter, let's say I make it AIT, it. We look look for this new word in our dictionary. It's not here, so probably we'll ditch this. Then we change it to B. B is not in the list dictionary. Then we change it to C, D, and we keep doing that till we hit right. Okay, if we keep changing the first letter, the H, with every alphabet, then we would not find a match in the word list, and so then we do the same for the second letter. We start from A till Z, and once we found the match, okay, then that word becomes our new current word. We increment our counter, and then we do the same with this word. Can the word, yeah, can it be length of the word? It cannot be greater than 10. Yeah, because if I was, I'm thinking of doing a recursion, and a big length word, would be very inefficient. All the words in word list are unique. Can I, so I can sort of check that if word list dot get word list dot length -1 equals end word, not if the end word, if the last element is not end word, then it's not a valid list. Then we can return false. Size. Boolean cannot be converted to int. What? Oh, 0, 0, 0. Here the end word is not the last word of the word list. So we okay. Let's say 5. See, one case or one case passes without any logic. Okay, now on to the main task. How should I do it? Well, I can do a recursion, obviously. Mm, mm. Hit. Mm, mm, mm. Hash table string breadth first search. Breadth first search. Breadth first search using Q. Okay. Well, first of all, we need a hash set for using contain operation. Set is hash set word list. And what we can do is once our hit becomes hot and we set our new current, then we can remove this hot from the set. That way we won't mm, Yeah, that way we will only visit it once. Q Q of Q of string Q new linked list. Q dot offer the first begin word while Q is not empty. While Q is not empty. Okay. For well, okay, string current word. We pop this word from whole, so we get the current word. And now I'm gonna for each letter, for each character, for each character in the current word, what I want is I want for int I is equal to a while I is smaller than or equal to z plus plus. Okay, now the main thing. I'm very bad with working with strings. That's my weak point. So I'm going to address that now. String and characters. I've never really got to work with characters and strings in Java that much. So so I'm just trying to think. I'm trying to think how would I turn each character around. I'm gonna make a new word. Well, I can use a string builder. Okay, we can use a string builder. Then I can I have H. How can I get access to the rest of the letter? H, I. Hmm. Hmm. Okay. Maybe I need I as 0. I is smaller than current word's length. Yes. And I plus plus. I'm not sure if there's a string. There's some good string method that can help me with this. Yeah. J J J. Character to change. Okay, character to change. Current word dot char at I. If c to change j is not equal to character to change string builder. SP is a new string builder, and SP SP plus equals current word dot substring from 0 till I plus SP plus J. Hang on. Well, let's see. 0 1 2 hit HIT when I'm changing the first letter, what I want is I want to A. Well, I would ask for a substring. Substring from 0 till 0 will return me nothing. Okay, and then I can add new character, and then I can ask for the rest of the string from I plus 1 till the size, and it should return me id. Okay, now when I want to change the second letter of him, okay, 0 till 1 will give me h. Okay, let's try. Let's just see in the code. J sp plus equals current. Just copy this. I plus 1 till current word. What size? Let's see. String. Let's break for now. Append. I'm sorry. Dot append. Append. Oh. Size. Cannot find the symbol. Length. Hash set. New hash. 97, 90. No. I want character. Char. Okay. So far good. Where are the rest of? Alright. Working as expected. Let's just see if it works for the entire string. Okay. Yep. Pretty neat. Now, what I want to see is once we have if okay, let's just convert it to a string. sp string, sp to string. Okay, I want to check if my sp string is not equal to well, we don't need this. It's not equal to current word. I guess I should use well, it's not equal to this. And if set contains, if our set contains this string, then we increment our result. Result plus plus, and we set new current hang on. Maybe I'm supposed to add the new string, new word to the queue, and set dot remove fine, and we break out of this loop. But we are still in this outer loop. How can we come out of here? Well, I can say that I can give a boolean. Has new word found. New word found. False. And new word found, as long as this is false. I can set this to true here. Okay. Honestly, it should work. We're successfully breaking out of this loop. Then we are breaking out of this loop. Q. Okay, let's just see. Q. Hmm. It's not print. What extra word are we getting? Hot dot lot log cog and dog. What? Dog. Okay, yeah, this is dog. But we can't go back, can we? If we found, if we, so if we found if we found the end word, that should be our signal to, okay, this was the last word. If the last, we immediately return. End word. So I want to say if substring equals end word, well, we then return result plus 1. There ought to be edge case, yes. Begin word A, C. A. Alright, we're starting from A. Just a sec, just a sec. Yeah, there was a noise out. The queue. A. Speed or equals n word. Definitely not. Speed to current word. Insert word contains S. B. A. I can write like if set contains begin word, then set dot remove begin word. It doesn't impact our usual cases. Okay. Hot dog dot. Hot dog dot. Hang on. The N word. Hang on. Was not used after all. Wasn't useful after all. But the N word is dog. So we only check till the dog. Three. Dot. When we started with hot. We got dot, and then we got expected 3. Output is 2. G. Dot dog. So what if Beacon word is present in the word list? In this case, begin word is present in the word list. So this will not do. Still do. B C. So it says something like if it does not contain end word, then we return false. I mean 0, 0. Okay. Now if the word list contains begin word as it does in these two cases, well, we started with hot. That would count as 1. D O T dot from hot it would become dot. Dot is present in the word list, so that would count as 2. From dot it would go to dog, so that would count as 3. I don't know, maybe can I say if that contains first word, then result plus for begin word. A B. It's not quite right, does it? Set dot remove word. Yep. Expected 2. That was 3. Yeah, I can't duct tape it like this. Okay, so begin word. We're starting from begin word, turning it into B. Then okay, is B our end word? No. Expected 3. Since we're starting from What's wrong? Something's not quite right. B. B. And then A again. Why A again? Well, let's also observe the behavior of the Q. What's in it and what's Q. B. Okay. Then okay. Okay, the B, once we add B into the Q, then we get B as current word. Okay, and then we start from A again. Okay, let's see. Let me see how I handled this case last time. Changes 1. Q visited. Okay. 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 I see. Visited. We need one more set. Set visited. Visited. New hash set. Why did we add begin word twice? Interesting. That's interesting. Changes. First of all, let's if visited if visited does not contain visited dot add strings. Still not there yet because here we are we increment the result only after coming out of this loop. Okay, fine. I still don't know computer data. Yes, I must have copied pasted this solution. I don't know. Okay, I think that was unintentional. Okay. Yep, that was unintentional. Let's go to R code. Result is 1 initially. Then we are not we in the submitted solution we are not iterating over the entire word length, and we don't need to. size. So when we size hit, so Q size, Q will have at initially it will have only one element. The size is 1, so this loop will run only once, and when we come out of the loop, okay, I got it. I think I got it, because in this solution we are not never popping elements, we are not removing elements from, we never removed any. No, here we have. So after removed the check, okay, converting the word, current word to an array, to character array, and then turning it back to string, and then checking that string. Okay. I'm not sure what to do now. Should I continue improving this one? Okay. I don't know, but I now know the right way to do it. Okay. I'll come back to this one in a couple of days again. For now, what is the time complexity of this? N square multiply n. Oh. 1, 2, 3. I only have 2 inner loops. Okay, I'll try to improve this solution if I could. Okay, this was a video. What's the time? 1 hour 38 minutes. Okay, quite a lot. Let's go today. It was good. Learned a lot. Yeah, I'll see myself tomorrow.